Hello everyone. I will introduce the paper Temporal Action Segmentation from Timestamp Supervision. The goal of action segmentation task is to predict an action label for each frame in the video. Some approach in full supervision is already successful. However, the annotation is a time-consuming work. Although weak supervision with the transcript can significantly reduce the annotation effort, but the performance is not satisfying. In this paper, we proposed to use timestamp supervision for the action segmentation task. There is only one frame is annotated in each action segment. This kind of annotation can be obtained by comparable effort to transcript. Besides the action order, it also gives partial location information of each action. In the framework, the segmentation model takes the input to predict classification scores. In timestamp supervision, we don't have the frame-wise action labels. There is only one frame has a label in each action. We propose an approach to generate pseudo-ground truth as the target of the loss function. The approach is to detect action changes. This picture shows the definition of timestamps and action changes. After detecting action changes, we can generate pseudo-ground truth by assigning each segment to the same label of its timestamp. To detect action change, we use the output of penultimate layer as the feature. The goal is to find the time that minimizes the following stamp-to-stamp energy function for each segment divided by timestamps. D denotes Euclidean distance. For example, if we want to find the action change TPI, we iterate all frames from Ti to Ti plus 1. Assume T hat is the current estimated time. It divides the frame into two clusters. In each cluster, Ci is the average vector. We calculate the sum of the distance between each feature and its average vector. The frame with the minimum score is the action change TPI. The idea of forward-backward action change detection is to consider the previous action change TPI minus 1 and the next action change TPI plus 1 to detect the TPI. The reason is if we already calculate TPI minus 1, then the frames from TPI minus 1 to Ti are assigned the same action label ATI. This information can be used to estimate the TPI. We call it the forward estimate. The same argument also holds if we start estimating action changes in reverse order. We call it the backward estimate. The final estimated TPI is the average of these two estimates. We have three losses: the classification loss, the smoothing loss, and the novel confidence loss. It penalizes the increase in confidence as we deviate from the annotated timestamp. The total loss is the sum of three losses. We design two baselines. The naive baseline directly uses the sparse annotations as the target. The uniform baseline assumes action labels change at the center frame between two consecutive timestamps. This is the result compared to two baselines. The naive baseline achieves a good frame-wise accuracy, but it suffers from a severe oversegmentation problem indicated by its low F1 and edit score. Because it only uses the sparse timestamps annotations for training and leaves a lot of ambiguity for frames without annotations. The uniform baseline reduces the oversegmentation error. However, the frame-wise accuracy is not good because the uniform assignment generates many wrong labels. The quality results also can show the naive baseline has a severe oversegmentation problem, and the uniform baseline tends to predict action labels uniformly. This is a quality result on a test video of breakfast dataset. We first show the action name from our prediction and ground truth, then indicate different actions in different colors. There is a bias between predicted action boundaries and ground truth, but not much. This table shows the comparison on breakfast dataset. Our approach can achieve comparable performance to fully supervised approaches using a tiny fraction of the annotations. In conclusion, we propose to use timestamp supervision for the action segmentation task. We introduced an approach to train a segmentation model using only timestamp annotations. We proposed a novel confidence loss that enforces monotonicity on the model confidence. All the results show that models trained with timestamp supervision can achieve comparable performance to the fully supervised setup. Thank you for your listening.